Assalamualaikum warahmatullahi wabarakatuh. My name is Daven Prima Alsyafi. I'm from 2 NIP1 and Group 8, and I want to presentate about my ISAS, my paper about implementation about Rabin-Karp algorithm. The definition of algorithm. An algorithm is a step-by-step method of solving a problem. It is commonly used for data processing, calculation, and other related computer and mathematical operation. And this is Rabin-Karp, the founder of the Rabin-Karp algorithm. On the left side there is Richard M. Karp, and right side is Michael Rabin. The Rabin-Karp algorithm for string matching was introduced in 1980 by M. Karp and Michael O. Rabin. With the use of hashing technique, make this algorithm different from other algorithm for efficiently matching the pattern of length M from the text N. And this is the example of the basic idea. So this is the simple explanation of the Rabin-Karp. Only J. And then this is how it works. So A is 1. So the first thing is we need to calculate 3 hash value. Of course, only 3 and then 3 and 3 again. That's how it works. That's how Rabin-Karp it works. 3, 3, 3. A, which is 1, 1, 1. And then we got 3 hash value. But in the pattern, which is AB 112 has 4th hash value. So there is no same. The text and the pattern, it's not same. It's not equal. So what we need to do is put out the first value of the text and then put into the three just like 3 box, just like 3 box, and put it into the box, the new one from just like it. So for example, we have the text like this, AB, which has 6 count of the alphabet, and the example of the pattern or the sentence that we want to match with the text. So example is AAB and have the 3 number. And then this is how it works. So for the first thing is how many alphabet that you want to, or the text is used. And so for in my case, just for the prevention, I use until the G alphabet, which is 10. So you can count it from 1, which is A, to maybe Z, which is 25, but in my case. So for example, we have the text like this, A, B, which has 6 count of the alphabet, and the example of the pattern or the sentence that we want to match with the text. So for example is A, B, and have the 3 number. And then this is how it works. So for the first thing is how many alphabet that you want to, or the text is used. And so for in my case, just for the prevention, I use until the G alphabet, which is 10. So you can count it from 1, which is A, to maybe Z, which is 25, but in my case. So for example, we have the text like this, A, B, formula. So D is 4, and then put it into, so the formula is M minus 1, which is 3, minus 1 is 2, and so on, 1 and 0. So after you count it and plus it, and the value is 421, like this, yes, and then match it with the text. So we have 11 alphabets, we need to match it, all of it. So the first one, just like before, 3, CCA, and use this formula, 3 minus 1, which is 2, 3 minus 2, which is 1, and so on. And we got 331. But the text value from the CCA, it's not the same as the pattern. So we need to search again, just like before, 3 again, and then 3 again, just like CCA, until we got the exact same value, maybe in this text, maybe in this alphabet. So if we already got the exact same value, then it will be stopped in there, because we already found it. We don't need to calculate it again, because the pattern that match with the text, or maybe the plagiarism, or maybe the plagiate alphabet, we already got it, so there is no use to calculate again. And this is the code that I use from some website. You can see code, and this is the data set. This is the data set for the implementation. So I choose 2 sample from the dataset, Muhammad Zaki and Muhammad Rafi. Muhammad Zaki and Muhammad Rafi. So this is the explanation. Why the output will be like this: pattern found at index 0, index 16, because in the code, because from the text, Muhammad Rizki and Muhammad Rafi have 2 sentences that match with the pattern Muhammad. As you can see, the code counts it from 0. So the pattern Muhammad M in this text is 0, so it will be found at the index 0, same value as the text. And then, as you can see, even the space have their own value, even the comma have their own value. So the Muhammad pattern is found on the first value on the 0 and 16, but the total of the text is 28. And this is the conclusion. This algorithm is used in detecting plagiarism, but Cannot Morris Pratt algorithm or Boyer-Moore string search algorithm is faster single pattern string than Rabin-Karp. However, it is an algorithm of a choice for multiple pattern search. If you want to find any of the large number fixed length patterns in a text, we can create a simple variant of the Rabin-Karp algorithm. So the suggestion is the effectivity of Rabin-Karp algorithm is to matching and find the plagiarism for any type of documents, text, etc. For efficiently, if you want faster searching than Rabin-Karp, there is such a way to do that. You can use Cannot Morris Pratt algorithm or Boyer-Moore string search algorithm. There is such an online website that you can use to do so, which is the program that can used for plagiarism. The plagiarism check program that you can download or use in that web. Okay, thank you for your attention, and thanks for watching. Assalamualaikum warahmatullahi wabarakatuh.